In this video, we introduce stored procedures, and we also talk a little bit about functions. Building on the previous video, we can write some procedural code just like we would do in Java or C# or PHP or JavaScript, using some particular syntaxes that are available to us in SQL. We can write conditional expressions, meaning we can create if-else statements to make decisions and control the flow of execution in our program. If you've had another programming language such as Java or C#, this should look familiar. The two significant differences that jump out immediately at me are the way we manipulate variables. We have to have the @ sign, I get those two confused. The @ sign in front of the variable name wherever we use it. When we declare it, for example, the first line of code on this slide, we declare a variable called myDate, and we put the @ sign in front of it. Now I just pronounce it as myDate, I don't pronounce it as @myDate. After we've declared the variable using the declare statement, we initialize it using a set statement. There are other ways as well, but set is standard. And then the other thing that jumps out at me that's different is that the delimiters in the if-else blocks are begin and end rather than curly braces as you would see in Java or C#. The word begin here replaces the curly brace that you would expect to see in more mainstream programming languages. So that's something else that might take some getting used to. But we indent the same way. The thinking is the same. We do conditional expressions to control execution flow. We can also create loops. And I encourage you to experiment with the SQL syntax, because you will be writing programs, for lack of a better term, in the assignments that you will have. And you will probably be writing stored procedures and user-defined functions when you get a job as a database developer or analyst or programmer. Also note that our strings are delimited by single quotes, not double quotes. In Java, for example, a string is delimited with double quotes, and a single character is delimited with single quotes. But here, a string is in single quotes, and then if we want to embed an apostrophe or a single quote in a string, we just put two strings in there, or two single quotes in there. We have the while construct in SQL to implement loops. Again, the difference, or a difference, between this and perhaps Java or C# is the fact that we're using begin and end as our loop block delimiters. You would expect it to look something like that in Java or in C#. And you probably also notice that we are not case sensitive in SQL. The keywords are not case sensitive, but we typically, by convention, use all uppercase letters for our keywords. And of course in Java, that would be all the correct spelling of while. You would have all lowercase letters when you wrote the while keyword in Java. I would encourage you to experiment with the code provided here and get comfortable with looping constructs and if-else constructs, because it's very easy to open a query window in SSMS and write some simple code and test it. All you have to do is paste it into the query window, and as long as your variables are declared and your syntax is correct, notice there's nothing here that has anything to do with data tables. We're just practicing logical constructs and syntax. And when we run this, it executes this loop 5 times. Inside the loop is a print statement, and it prints out the value of the counter variable from 0 through 4. You could implement this with a goto, but I wouldn't like you very much, and I strongly suggest that you don't do that. Goto is a bad idea in programming. It creates something called spaghetti code, and it may be a shortcut for you to get past a problem in a hurry, but it creates technical debt that you or someone else will have to fix later on, and it will open the door for errors because gotos make the code difficult to follow, and if code is difficult to follow, it's difficult to understand. If code is difficult to understand, it is problematic to improve it or fix it. Here's a comment. The comments are delimited by 2 dashes. Some things you may want to do for practice would be make the loop print from 4 down to 0. That would be good practice in just making a modification to this existing code. You could make the loop print only even numbers. That would be good practice, doing a little bit of arithmetic computation and modifying the loop again. You could do a little experimentation. What happens if you add a statement in your code that causes a 0 divide? And you might want to try that with integers and floating point numbers to see if there's a different result. Think about what happens in Java or C# if you divide by 0, and there is a different result. Your program behaves differently if you divide integers by 0 than if you divide floating point numbers by 0. We would be curious to know what happens when you do that in SQL. We'd also be curious to know what happens when an integer overflows. Take the maximum value you can store in an integer, add 1 to it, and see what the program does. Does it crash? Does it continue on? Does it overflow? Does it underflow? Does it do something unexpected? These are all things you can do to teach yourself a little bit about SQL programming and get practice with the syntax at the same time. Reviewing our coding standards: when you write a program, when you write a script, you are expected to document the script thoroughly. This is a good practice to take into the working world with you. Keep in mind that the standards will change. When you are employed doing professional work, you will probably be told how to document. Hopefully you will be told. Hopefully you will realize there is a standard at your place of employment. I can almost guarantee you that your standard will not look like this, because standards vary from company to company and from programmer to programmer. This is a standard we will follow because we need something to follow. Is it 100% perfect? No. Does it apply in all situations? In this class it does. In the real world it probably does not. So I'm not telling you that when you get a job and when you become a developer you must follow our coding standards. I'm not saying that in any way, shape, or form. I am saying that it is good practice for you to follow a standard, to understand the importance of a standard, Remember that code is written once and read many times. Therefore, it is crucial for you to leave a trail of breadcrumbs in the form of documentation. What did you do? Why did you do it? Where did you get your sources? Did you find information on the net? Did someone help you? Is there a third party that needs to be referenced? Think about what you would want to know in 6 months, in a year, in 5 years, or even 10 years. When you revisit this code, or when someone else revisits this code, what will they want to know? What do you want to tell your future self? As you get more experience writing code, your documentation style will change. Some things that you are doing now may look completely redundant and even to the point of being silly when you go back and revisit this code later. But that's okay. We're developing good habits. We're understanding how to work. This is what I want to see when you turn in a program or a script that you write. Obviously, this will vary a little bit. You won't use my name. You won't use my email address. The course title will change. The course is not called Introduction to Database Things. The due date will change, and then you will give me a description of what you did. This is the starting point for your documentation. I expect to see this on all of your work. Stored procedures. We can store logic. We can create a script and store it in the database as a database object called a stored procedure. The stored procedure is good for changing the state of the database, meaning creating objects, adding rows to tables, deleting rows from tables, editing existing rows in tables, modifying what the database has in it. If we need to write a script that adds a set of users, every Monday morning all the people that we just got hired need to be added to our database so they have permissions to access the tables. We could write a script to add those users. We could also write a script to add the equivalent logins for those users. We can create tables. We can create other stored procedures. We can create views. Anything that exists in the database as an object, we can write a stored procedure to create or manipulate. Of course, when you run the stored procedure, you need permission to do whatever that stored procedure is going to want to do, meaning your stored procedure could crash and burn gloriously if you try to run it without appropriate permissions, and you won't know that until the procedure executes. Another type of scripting using the exact same syntax, the exact same constructs, is a user-defined function or a UDF. The difference is a UDF cannot create things in the database. It's good for perhaps reading a view, reading the results of a query, doing some computations, and returning a value or a set of values. So UDFs are more limited by design, but they can still be very powerful tools. And we are typically writing UDFs for other people to use in their applications. Someone will come to you and say, I need to know who all the stores are in Ohio that sell ice cream. Well, being the DBA, you would understand the schema of the database, and you would write a view that extracted all the stores in Ohio that sold ice cream, and then you could write a UDF that returned that data set, and then other developers could use that UDF to populate controls on reports or controls on web pages. In the upcoming slides, we will do a little bit of data manipulation. Here is a table that you can use. If you've already created this table in a previous exercise, you may want to clear all the rows out of it. If not, you'll see as we go along what needs to be done. I already have this table created. There's tpet, and I will manipulate tpet as we go along just to make sure that it's empty. I can see that it has 0 rows in it, and I'm good to go. I already ran this script and I'm good to go. To create a stored procedure, we can use SSMS to expedite some of the housekeeping chores. We open up the programmability folder, right-click on stored procedures, select new stored procedure. That's how I do it. There are other ways as well. Programmability, stored procedures, new stored procedure. You get this. It's a little bit overwhelming. SSMS generates this template for you using another stored procedure that's built in, and we can edit this down a little bit. We don't necessarily need all of this right now, and then as you get more advanced you can leave things in or add more components to it. What I do is edit it down to this. I'm just trying to keep things simple at this point. So I provided a name. Now this isn't the best name, but in a lot of my classes where we have students all working in the same database, I need a way to differentiate one stored procedure from another, and I use the student's college ID, their 6+2 so to speak, as a prefix. A lot of times in the real world you're going to have a naming convention for your standard procedures. For your stored procedures would probably be something like that, where SP, short for stored procedure, is the prefix that you use. And that way when you see a reference to that programming, you know that it's a stored procedure because it starts with SP. But I am going to use that simply because it lets me differentiate my stored procedure from everybody else's who might be in the database. Again, not the best naming convention, but it works in this context. This particular stored procedure is going to accept a parameter. If you think of a stored procedure as a method, then this is the parameter passed to the method. So if you've had Java or C# or any language that implements methods, this is the same thinking, except instead of a method we call it a procedure. And then the body of the stored procedure is actually everything between the begin and the end. Everything else in here is just boilerplate needed to set up the creation of the SP. So you really put the programming that you're going to do inside that begin and end block. Here is where you will put your comment header. Refer back to the previous slide and include all the information I asked you to provide when you write a program for this class. Your name, creation date is fine, the due date is important, the description of what it does, the course number, all those things that are important to us when we write a submission for this class. What does this stored procedure do? The only thing it does is insert a row into the pet table using the value of the parameter as the value of the pet column. This should look familiar. We've done insert statements before. The only thing new here is a reference to the pet variable, which if you refer back you can see that was the parameter passed to the method, meaning when we invoke this method we have to provide the name of a pet, which will be added to the table. You cannot invoke this method without providing the name of a pet. If you try to do that it will probably fail, and it would not be a good idea based on the way we've designed it. Also make sure that you edit the use command to reflect your student database that was assigned to you. So when the stored procedure is created, it will be stored in your database and not accidentally tried to be stored somewhere else, which would probably fail miserably because you don't have permission to store things anywhere else. And once we run the script, we get the stored procedure appearing in the stored procedures folder inside of the programmability folder, I will go ahead and do that. Just to make sure that it's not already there, I look in the stored procedures folder and I have one called create login and one called create table, which aren't relevant to us right now. So I can select new stored procedure, and as we saw earlier, I would get this. I would have to edit this down the way we did in the slide, but what I'm going to do is just copy and paste what was on the slide, taken directly off the slide, right there, pasted directly into a query window. I can change this. And then when I run this entire script, it will create the stored procedure in the stored procedures folder in this database, NICOMP. Be careful that you don't highlight anything, because if you do, it will only execute what you've highlighted, and when I click execute, it fails miserably because there is no thing called NICOMP that's executable. Unhighlight that. Nothing's highlighted. Click execute. Be careful to differentiate now between what you just executed and the concept of a stored procedure. What you executed was a script to create the stored procedure, not to run the stored procedure. We didn't add a row to the pet table. We did not execute this code. We simply ran a script to create this code in the form of a stored procedure. If I refresh this folder, there's the add pet stored procedure that I just created. If I close this, because I don't really need it anymore, and let's just close this one to eliminate confusion, and I see that I have a stored procedure called NICHOLDW underscore add pet. If I realize I need to make an edit to this, I can select modify. And after a brief pause, SSMS builds another template. And notice the difference is, instead of create procedure, we're now running alter procedure, meaning that the stored procedure exists, but we're going to make changes to it. And I could go in here and add more logic between the begin and the end to change the functionality of an existing stored procedure. Make sure you know the difference between alter procedure and create procedure. I'm not going to do that. I'll just close this right now. After we've created a stored procedure, we'd like to see it run, because we don't deliver things without testing them thoroughly. To execute a stored procedure, I'm demonstrating here, maybe I don't know how to do that, maybe I've forgotten, and I go to a search engine and I type in a search phrase. Remember, this is a skill that employers want you to have. You are encouraged to use search engines to solve problems. You are certainly welcome to crack a book and read through a book linearly to try to find these answers, but we have found through experience that it is quicker and more efficient to use a search engine to find out how to do simple tasks. In order to learn how to do this simple task, I typed in a search phrase. It's a rather extensive search phrase. SQL Server execute a stored procedure from the query window. I put that into the search bar. I clicked the search button, and I got some very helpful help. It says I can execute a stored procedure by right-clicking on the stored procedure and selecting execute, meaning SSMS will do it for me. I flip back over to SSMS. I right-click on the stored procedure in the stored procedures folder. I select execute. After a brief pause, I get another dialog. This stored procedure has not yet been executed. We're still getting ready to do that. And here is a place where I can put in a value for that parameter, meaning SSMS knows that my stored procedure requires a parameter. it provides me an opportunity to enter a value for that parameter. If your stored procedure is written in such a way that null parameters are acceptable and ours is not, you can just check this box and you don't have to put in a parameter. We are not going to do that. Click OK. SSMS writes more code for us. Here's another little script. This script actually has been executed already. And when I clicked OK on that dialog box, SSMS generated this script and ran this script. And here is the logic that actually executes the stored procedure. So if you want to execute a stored procedure on your own through SSMS, you could open a new query window and type in a subset of this code. And then at the bottom is the result of the stored procedure, which is a record set with one row with the value of 0 in it because the stored procedure did not return anything that we're particularly interested in. 0 means all is well. We're not worried about it. But I did add a row to the table. You can see there's the parameter being passed to the stored procedure with the value parrot, which is what I typed into that dialog box. And to make sure that this worked, I can go back to the pet table. Remember, it had 0 rows in it earlier. Now it has one row. And that row has the word parrot in the pet column, meaning my stored procedure did execute. It did add a row to the pet table. Why do we do this? Why don't we just open SSMS, select Edit Top 200 Rows, and add rows to the table? One reason is because most tables have more than 200 rows, and that tool quickly becomes outdated. Another reason is we don't want to give SSMS to our customers and let them edit tables directly like that. We create a user interface. And in order to make that user interface effective, we need to write stored procedures that support things users want to do and developers want to implement. It also allows us to abstract knowledge of the database, meaning if you can call my stored procedure and pass it the word parrot, it will add a parrot to the pet table. You don't know anything about the pet table. You don't know how many tables were affected. You don't know if that was the primary key. You don't know anything. So I have reduced your dependency on the schema to your ability to call a simple stored procedure, and you don't have to stop and think twice about it. As a GUI developer, as a middleware developer, you don't need to know the structure of my tables. You need to know very little about my schema. You just need to call my stored procedure. We can also build smarts into the stored procedure, such as validation, to prevent you from doing things that we don't want done to our database. Perhaps I don't want pets that are blank. Perhaps I don't want pets with the word parrot in them because I'm allergic to birds. I can prevent you from doing that by writing validation logic into that stored procedure. Now that validation logic becomes part of the database because, as you saw, the stored procedure travels with all the other objects in that database. I don't have to worry about it being separated somehow and becoming disconnected from my database. As long as everyone calls that stored procedure to add a pet, they have to go through my gatekeeping logic to add a pet to the table. And that's quite easily accomplished by not giving them permission to do anything else but run stored procedures, so they won't accidentally be able to put things into the pet table without using my stored procedure. Revisiting the stored procedure that we wrote, if we execute it a second time, it should fail because parrot was already in the table, and parrot is the natural key of that table, meaning we can't have two parrots in the table. I don't know why anyone will want two parrots. So I don't have to do anything except try to run this again to demonstrate the problem. And instead of getting a nice return value of 0, I get this. Cannot insert duplicate key into object pet, meaning that this word parrot is already in the table as a natural key rather, and you cannot duplicate natural keys. So that stored procedure could crash and burn because I got some data that was at odds with what was already in the table. We don't want our stored procedure to fail dramatically. We don't want users to have to worry about message 2601 level 14 state 1. That would be a very bad thing to expect our GUI developers or our middleware developers to have to dig in to the database and the database documentation to try to figure out what went wrong with this stored procedure. We need to eliminate that burden from those developers. We don't want them knocking on our door at Friday at 5 o'clock when we're getting ready to go home and asking us to fix these kind of problems. We can add a try-catch. In this try-catch logic, if something goes wrong, instead of a nasty red error message appearing in a window that the developer probably doesn't even have access to, we can catch the error and do something a little more graceful. And you can see the choice I've made here is to return a 1 instead of a 0, meaning that something went wrong. And then the developer who's using my SP can hopefully take some appropriate action, meaning read my documentation and find out what a 1 means. But this is much more desirable than having it just fail and leaving the developers to fend for themselves. Admittedly, this isn't the best error handling, but it is some error handling, and it is a start at solving the problem. Here's another thing I can do. I've still got the try-catch, but I'm also checking to see if the pet is blank. If a developer is trying to sneak in the blank pet type, so I do an L trim and an R trim, a left trim and a right trim to remove leading and trailing blanks, and then I calculate the length of what's left. And if the length of that pet parameter after removing leading and trailing blanks is 0, then I am deciding that they are trying to send me a blank pet name, which I don't want. You shouldn't have a pet with a blank name. The poor pet will never know what it is. And I throw an error. I throw error 50,001, and I return the error message invalid animal. Now, if the developer is doing things correctly, they will receive that error message and they can react to it appropriately. We've taken a little bit more proactive approach to refusing to let other people put invalid data into our database. We'll talk more about these stored procedures in this other database a little bit farther down the road. Let's get a little more meta, and let's look at why stored procedures are not always a good idea. Remember that SQL is an interpreted language. It's not compiled. And I know that when you write a select statement, it is analyzed and it has an execution plan. But we're talking about just straight procedural code here, loops and ifs and elses and throws and catches, and a lot of potentially a lot of calculations. So it is procedural code as far as we're concerned at this point, and it is interpreted, meaning that it's executed from top to bottom. It's not processed into an intermediate language. It's not processed into machine language. And that can lead to a slower result than a compiled or a hybrid language. So Java and C#, as a rule, are going to be faster than SQL. And we're going to try to make this point here in this demonstration. I have gone to projectoiler.net and I have implemented problem 4 at that website. If you don't have a Project Euler account, you should create one. They are free. It is a good repository of programming exercises, and it is a good way to build your programming skills as well as your reputation. You can point to your project or success when you apply for jobs, and you can build your skills that way. I decided to implement problem 4. Now, I didn't show you the whole script because I don't have to at this point, but what I want to show you is what's at the bottom. Project Euler problem 4, which is a relatively simple piece of code. It's not complex at all. Took over a minute to execute. Okay, you haven't seen the script yet. I didn't do anything out of the ordinary. I wrote a very straightforward set of logic, and it took over a minute. So keep that in mind. There's the actual code that I wrote. If you'd like to dig into it, you're welcome to do that. You will see that there is a while loop, and that there is an if, and then there is another if. Not a complex piece of logic in any way. We're manipulating some integers, we're manipulating a string, and we're timing the execution of this entire script. So what you saw on the previous slide is the result of running this code. You are welcome to grab this code and you are welcome to execute it, and you will see that it literally takes a minute to run, and I will sing a Beyonce song to you as we're waiting for this to run. Actually, no, I won't. You don't want that to happen. But after a minute goes by, we will see that it took quite a while to do this work. Now, we don't know if this is good or bad because we don't have a benchmark against any other execution environment. I have given you a benchmark. I wrote the same program in Java. The logic is the same. The syntax is a little different because we use different keywords and we use different delimiters, but it does the same kind of calculations in the same order using the same algorithm. It takes 0.172 seconds. It takes less than 1/5 of the time that it takes to run when I implemented an SQL. This one's still running. Now remember, your results will vary because of how busy our server is when you run your test case, and so it may be a little bit more, a little bit less. I've also provided you this Java program if you'd like to load it into Eclipse and experiment with it yourself, but you can see when I run it here, you can see on the slide that it took 0.172 seconds or 172 milliseconds, and this is still running. What we're seeing here is that sometimes you have to stop and think about scalability. If we're running this script once, as we are here, there, it just finished. It looks like it took even longer than 1 minute, minute and a half perhaps. Running this script once, waiting a minute and a half, no big deal. We can do that. We can sing a Beyonce song while the script runs, and we can go get a drink of water and come back, and it's okay. We can wait a minute and a half. However, if this script has to run 1,000 times an hour in support of a very popular website or in support of an application that someone else is developing, this is probably bad news. Our users probably don't want to wait a minute and a half for their script to run when the script could run in 0.172 seconds or less using some other programming language. The point we're making here is just because you can doesn't mean you should. And you hopefully recognize this clip from Jurassic Park. Sometimes implementing something in SQL is not the best idea. Advantages: it runs on the server side in a secure environment. It runs very, very close to the database. Disadvantages: it may take an excessively long time to run and it may not scale very well. Just something to think about and be aware of, because you as a developer are going to be working in an enterprise environment more often than not. And in an enterprise environment, your application is going to be executed by many different users in many different locations across the internet, and sometimes we need to optimize performance at the expense of other factors, and we may need to write something in Java when it was initially written in SQL and just simply runs inefficiently.